Today, I will lead you to continue learning about quadratic functions, univariate quadratic equations, and inequalities. In the last class, we learned to look at quadratic equations and inequalities from the perspective of quadratic functions, discovered the connections between the three, and summarized how to solve quadratic inequalities using the idea of functions and the combination of numbers and shapes. Please first recall the content we summarized in the previous class. In the last class, we focused on summarizing the correspondence between solutions of quadratic functions, quadratic equations, and inequalities. Do you all remember this table? Let's interpret the content of this table together. Firstly, starting from the quadratic function, taking the coefficient of the quadratic term as a positive number as an example, we will examine it in three categories: greater than 0, equal to 0, and less than 0. Firstly, if the coefficient of the quadratic term is positive, then the corresponding parabolic opening is upward. The first type of situation is that the discriminant is greater than 0. Please see that the parabola has two different intersection points with the horizontal axis, which means that the quadratic function has two different zeros. When the discriminant is greater than 0, a quadratic equation has two unequal real roots. Of course, we need to focus on the solution sets of two common inequalities. What is the set of solutions where y is greater than 0? We can speak by looking at the graph, which corresponds to the range of x values for the part of the parabola above the x-axis. It should be x less than x1 or x greater than x2, and it should be expressed in the language of sets. So what is the set of solutions where y is less than 0? X is greater than x1 and less than x2. This is the first type of situation where, when we know the characteristics of the quadratic function graph, we can obtain the corresponding solution set of equations and inequalities from the graph. Okay, please take a look at the second scenario where the discriminant is 0. The solution set greater than 0 is x belonging to R, and x is not equal to negative b divided by 2a. So, what about less than 0? As shown in the picture, it is an empty set. The third type of situation is the solution set where the discriminant is less than 0 and y is greater than 0. Well, some students say it's very easy. X belongs to R. So what about the solution set where y is less than 0? It's an empty set. We can find through this interpretation that it fully embodies the idea of functions and the method of combining numerical graphics. Besides, we can also understand the commonly used language forms in mathematics. Everyone, one is the graphical language of mathematics, and the other is the symbolic language of mathematics. I have collected several questions compiled by classmates here. Everyone can take a look and see that they are all problems of solving quadratic inequalities. Of course, there are slight differences between the questions. The first two are strict inequalities without an equal sign, while the last two are non-strict inequalities with an equal sign. Of course, we can see that the first three have positive quadratic coefficients, but there are also differences between them. The fourth quadratic coefficient is negative. In class, we only choose one question to solve, and everyone else completes the rest of the questions yourselves outside of class. Let's take a look at question 4. The original inequality is equivalent to x squared plus 5x minus 6, which is greater than or equal to 0. We convert the coefficient of the quadratic term from -1 to +1 using the basic property of the inequality that multiplying both sides by -1 does not equal the change in direction. Then we need to draw a quadratic function graph. We can easily determine that the parabolic opening is upward and has two 0 points. One is -6 and the other is 1. So combined with the image, it can be concluded that the solution set is x less than or equal to -6 or x greater than or equal to +1. Note that the result must be expressed in the language of the set. Can I solve the problem without changing the quadratic coefficient? Of course, you can directly create a quadratic function y equal to -x squared minus 5x plus 6. Here, it should be noted that the opening direction of the parabola is downward, and there are still two 0 points, -6 and 1. We obtain x less than or equal to -6 or x greater than or equal to +1, and the results of the two methods are the same. Solving quadratic inequalities is a fundamental skill for mastering high school mathematics, and we will encounter it in many topics in the future. Everyone, please take a look at example 1. First, let's review the question. When x is a real number, does it make sense to add x squared to the root and subtract 12 from it? First, everyone needs to clarify the mathematical objects and relationships given in the problem. Here is a quadratic root equation, and the range of the square root under the quadratic root sign is non-negative, that is, greater than or equal to 0. In this way, by examining the problem and analyzing it through understanding, we can transform it into a problem of solving quadratic inequalities. Everyone here needs to understand the observation, analysis, and transformation of the topic. We still use the combination of numbers and shapes, as well as the idea of functions, to create corresponding graphs and obtain 0, -4, and 3. Then, from the image, it can be concluded that if and only if x is less than or equal to -4 or x is greater than or equal to +3, this radical is meaningful. Here, we remind everyone again that the result should be expressed in the language form of a set. Through this question, we can understand that many problems can be transformed into solving quadratic inequalities after our analysis. So let's take a look at the application of quadratic inequalities in practical problems. Please refer to example 2. A vehicle manufacturing plant has introduced a motorcycle assembly line, and there is a relationship between the number of motorcycles produced on this line x in units of vehicles and the value created y in units of yuan as follows. Y is equal to -20x squared plus 2200x. If the factory wants to create more than 60,000 yuans in value using this assembly line within a week, how many motorcycles should be produced approximately within a week? The question provides two quantities x and y and their functional relationship, which is a quadratic function relationship. What does it mean to create value of over 60,000 yuans? That is to say, if y is greater than 60,000, we can easily list the corresponding quadratic inequality. Of course, for text questions with practical problem backgrounds, everyone should pay attention to the methods, steps, and standardization of answering. Okay, the factory should produce approximately x motorcycles within a week. According to the question, we can easily obtain this quadratic inequality. Our goal is to solve the range of x values in this quadratic inequality. Of course, when students look at it, they realize that the coefficients of this inequality are quite complex and large. To simplify the calculation, we can equivalently simplify it. According to the basic properties of the inequality, dividing both sides by -20 yields x minus 110x plus 3000, which is less than 0. Find two solutions and two zeros. One is 50 and the other is 60. Then we make the corresponding function graph and see the results from the graph. Of course, some people say that the result should take all real numbers between 50 and 60. Hey, that classmate said it's not true. Why is that? Because x has practical significance, representing the number of motorcycles, it should have a range of values and be a positive integer. In this case, when answering questions, we should pay attention that producing 51 to 59 vehicles can earn a value of over 60,000 yuans. Through this question, everyone can learn how to analyze and solve text questions with practical problem backgrounds, and pay attention to the standardization of answering questions. Of course, when solving inequalities, 2 points should be noted. Firstly, the equivalence simplification of inequalities. Secondly, attention should be paid to the range of variable values in practical problems. Let's take a look at example 3. There is a quadratic relationship between the braking distance s in meters of a certain car on a cement road and the vehicle speed v in kilometers per hour before braking. In a traffic accident, the braking distance of this car was measured to be greater than 39.5 meters. So, what is the minimum speed of this car before braking? The result is accurate to 1 kilometer per hour. Through the examination of the topic, it was found that there are similarities with the previous question, where a quadratic function relationship was given between two variables. What does it mean that the braking distance is greater than 39.5? This has given us an unequal relationship, and we need to extract it. From the meaning of the question, it can be inferred that the sum of 1/20th of v and 1/18th of v squared is greater than 39.5. Multiply both sides of the inequality by 180, and the direction of the inequality remains unchanged. The square of v plus 9v minus 7110 is greater than 0. Here we use the root finding formula. Everyone, v1 and v2 are the two zeros of a function and the two real roots of a quadratic equation. v1 and v2 are two irrational numbers, where v1 is less than 0 and v2 is greater than 0. So what should be the result? Someone said, isn't that v less than v1 or v greater than v2? Think again. V should be greater than 0. Everyone should pay attention to the range of actual problem variables, so v should be greater than v2. v2 is an irrational number, and we need to use a calculator to approximate it. After approximate calculation, we can conclude that V2 is greater than 79.9 and less than 80, measured in kilometers per hour. If V is greater than V2, then V should be greater than or equal to 80. Therefore, the vehicle speed before braking should be at least 80 kilometers per hour. In this way, we can infer the approximate speed of the car before braking based on the braking distance, mathematical models, and thinking methods. If the speed limit on this section is 70 kilometers per hour, then according to mathematical methods, the vehicle speed is at least 80 kilometers per hour, and it is determined that he must have been speeding. Have you experienced the application of quadratic inequalities in many problems, including practical problems, through the study of the above question? Have you realized the intuitiveness and simplicity of using function graphs to solve inequalities? Do you have any successful experiences or lessons from mistakes? Please summarize for yourself and further study and think outside of class.